Hello and welcome back for section 1.3 on Venn and Euler diagrams. So Euler spelled a little bit different than the way it's pronounced, but it's a last name just like John Venn. Venn is his last name. Leonard Euler is also a last name. They were sort of forerunners in set theory work. It's actually a newer branch of math than calculus is. So we'll start with the Venn diagrams. And we'll stick to 2 sets. In your next course, you'll look at 3-set Venn diagrams. So A is going to be a subset of universal set U. B is also going to be a subset of universal set U. So then the Venn diagram depicts the universal set, which we label as U. Make sure that you're labeling your diagrams as just a rectangular box. So everything in our universal set is somewhere in this rectangular box. And then for a Venn diagram, we just draw 2 overlapping circles. So within this first circle would be everything that's in set A as well as the universal set. So everything in the intersection of A and U. And set B, again, I mentioned the overlapping circles. So there is set B. So everything in the second circle is in set B. Everything in the overlap is in all 3. It's within set A, it's within set B, and it's within the universal set. So we've basically cut this into 4 distinct regions. So regions 1 through 4. So region 1 would be elements that are in A but not in B. Region 2, elements that are in both set A and in set B. Region 3, similar to region 1, except now the elements are in B but not in A. And then region 4, that would be something from the universal set that was not covered in the 2 original sets. So 1 is in A, not in B. 2 is in both A and B. 3 is in B, not in A. And 4 in U, not in A, not in B. So neither A nor B. So these are really used to sort of depict more complex ideas about sets and elements. So one thing they have us do is list out elements and regions or shade them. So we'll start with A intersection B. So region A is actually 2 separate ones. A is covered by 1 and 2, and we're intersecting that with B. B contains 2 and 3. And if you'll recall from last section, intersection, we want only the things in both. The only region that's in both lists is region 2. So we would sketch a Venn diagram and shade only region 2. So there's our universal set U, set A, set B, and then regions 1, 2, 3, and 4. And we would shade in only region 2. So let me give you all a few of these to try. So do the list as well as the shading on A union B, B complement, A union B complement, A union B, and grouping symbols complement. This last one we'll do together, but at least try these first 3. So go ahead and pause it. We'll return when you're done. Okay, welcome back. So we'll start with our list. So again, A covers regions 1 and 2. B covers regions 2 and 3. Union, hopefully you remember from our 1.2 work, union is everything. So if it's in one list or the other list or both, we get to keep it. So this will cover regions 1 and 2 because they were listed in this first part. 2's already covered, but 3 also is included because of B. So we would shade for A union B, regions 1, 2, and 3. So we draw our box. There's our universal set U. Within it we have set A and set B. And region 1, region 2, region 3, region 4 being outside. So A union B, I would shade in region 1 as well as 2 as well as 3. So everything within the circles is shaded for the union. All right, so B complement. So I want the complement of sets 2 and 3. So I want everything within the universal set that's not included in region 2 and 3, so that would be region 1 and 4. So that's what I'll shade. So universal set labeled as U, left side is usually our A, right side is usually our B. It doesn't always have to be A's and B's. It can be J's and K's or F's and G's. A and B is just sort of the generic starter one. Other letters would still work the same way because remember we could give sets other names than just A and B. So then our regions, region 1, region 2, region 3, and region 4. So this time we want everything except what is in B. So that would be region 1 and region 4 only. So everything outside of the circle. The one that probably took you the most time, A union B complement. So A, we've already seen was region 1 and region 2. B complement we saw in the previous problem was regions 1 and 4. And since we want the union, anything in this list we keep. So we keep 1, we keep 2. I don't see a 3 anywhere in that list, so we'll skip that. I do see a 4 though. So everything except for region 3 will be shaded in my drawing. So there's our Venn diagram starting, the box for the universal set U. The circle is for set A and set B. And then region 1, region 2, region 3, and region 4. So we're shading everybody except for 3. And these labels are important. Don't forget to include them when you're making your Venn diagrams. All right, so the one that I said we would do together, it looks almost the same. There's one key difference between these last two, and that is parentheses. Now, just like in your work in just regular algebra problems, parentheses still mean take care of the operations in here first. So when finding A union B quantity complement, first I'll figure out what A union B looks like, and then take the complement of that. So A union B, that would be regions 1, 2, and 3. And we want the complement of that. So the complement of regions 1, 2, and 3, everything that's in our universal set except for 1, 2, and 3. So that would be region 4. So our box, which we label as universal set U, our 2 overlapping circles, which we label as set A and set B, which breaks us into our 4 regions, 1, 2, 3, and 4. So this time it's region 4 only. So notice that the parentheses do matter. We did not shade the same areas. We didn't keep the same stuff based on whether we did have parentheses or did not have parentheses. Now, if we know what elements are in A, B, and U, then we can place the elements in the Venn diagram. One important thing to remember, this is one key. Each element may be placed only once. So one entry, we can't have one element appearing in multiple places, and we don't want to repeatedly list the same element in the same region. So for this first example of placing elements in a Venn diagram, our universal set is going to be just the counting numbers through 9. So single digit counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And for this example, set A will contain 2, 4, 6, and 8. Set B will contain 3, 6, and 9. So if we were going with the set builder version, A would be a set of all x such that x is a single digit multiple of 2 within the counting numbers, and B would be the set of all x such that x is a single digit counting number that is a multiple of 3. So we start the same way as before. We draw our universal set U, our nice little rectangle there. We have the 2 overlapping circles for set A and set B, which cuts us into regions 1, 2, 3, and 4. And when we have all of this information, we want to start from the middle. We want to start from the overlap, any elements that are in both set A and in set B. So notice 6 is in both set A and set B. It's also in our universal set. So in the universal set puts us in the box. The fact that it's in A says we're in the box and in this circle. The fact that it's also in B says we're in the box and in this circle. So it's all the way in the center. So there's our first element placed in the drawing. 3 and 9 don't appear in A. They do appear in B, so they're going to go in region 3. And notice I'm just lightly crossing them off as I go. I still need to be able to kind of read them. See if you can figure out what should go in region 1. So hopefully you figured out that in region 1, it would be the rest of the set A that hasn't already been placed. So we've already placed the 6. I'm not going to be able to put that down again, but the 2 hasn't been written down yet, but it is within the universal set because it's in this list, and it is within A because it's in that list. So that would go in region 1. Same thing with the 4, same thing with the 8. So now I've also placed a 2, a 4, and an 8. So that's everything that's in A, everything that's in B, but we're not done. Notice that there are still some elements in the universal set that have not been placed yet. Those will go in the box, but outside of the circles. In other words, region 4. So a 1 will go out here, a 5 will go out here, and a 7 will go out here in region 4. So they're still inside the box, but they're outside of the circles. They're not in A, they're not in B. So then we can use that to find various sets. We can use our drawing. So for example, they may ask us to find B complement. So recall from the previous page, B complement, everything that was not in region B. Regions covered by B were 2 and 3, so we're looking at anything in 1 and anything in 4. And this will be listed then in set notation. Specifically, we're going to go with just roster notation. So we have the 2, the 4, and the 8 from region 1, the 1, the 5, and the 7 from region 4. And then we just close our brace. A intersection B complement. A intersection B is region 2, so I want the complement of region 2, which would be regions 1, 3, and 4. So then I'll just go to my drawing and say that A intersection B complement, set containing everything from 1, so 2, 4, and 8, everything from 3, so 3 and 9, and everything from region 4, 1, 5, and 7, and we close it on up. So we'll try A union B complement, no parentheses this time. So remember, A is regions 1 and 2. B complement, everything outside of circle B, so that would be 1 and 4. So the union of that, I need everything out of 1, everything out of 2, everything out of 4. So union, we take it all. If it's in this part or both, we keep it in the union. So A union B complement. Again, that's a set, so I open it with the brace. I've drawn prettier braces than that, but nevertheless, here we go. So everything from region 1. So 2, the 4, and the 8. Everything from region 2, so that would be just the 6. And everything from region 4, 1, 5, and 7. and then we just close the brace. Alright, so I'm going to give you your own set to play with to sketch a Venn diagram and then use it to find various sets. So your universal set will be the Hindu Arabic digits. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Everything we have a single character for in our number system. And let's see, for your set A, we'll make that 2, 3, 5, and 7. And for your set B, let's see, we'll have a 5, a 6, and a 7. So see if you can draw the Venn diagram and then find A complement, A union B in parentheses complement, and A complement intersection B. So go ahead, pause the video, and give that a try. Okay, welcome back. So I'll start with the Venn diagram. So here's our universal set U, which I'll just draw a nice big box here. Two overlapping circles. Set A and set B, which cuts us into regions 1, 2, 3, and 4. So as you draw more of these, this should start becoming more and more almost automatic. It seems like a lot the first couple examples, but you'll notice that every time we hit the Venn diagrams, we have those same 4 labels and the same names for each of the parts. And again, sometimes we'll name this set D. If this is called set D, just put a D here. If this is called set Q, put a Q here. But the basic setup for the Venn diagram will still look the same. All right, so putting our elements in, I'm looking for, starting in region 2, the things that are in both set A and set B, and that would be just the 5 in this case. Sometimes it's multiple things. In this case, it was just the 5. Things that are in set A but not in set B, region 1, so that would be a 2, a 3, and a 7. And I'll go ahead and lightly cross those out. Things that are in B but not in set A, that would be a 6 and a 7. Oh, my apologies. I caught an error there. A 7 also belongs in our overlap. My apologies there. So there's our 7 in the overlap. So 5 and 7 are in region 2. 6 is the only element in region 3. So that's one advantage of lightly crossing those out. If you go to place it somewhere else and you see you've already used it, go ahead and take advantage of that. Go back and proofread your work. Okay, so we have 2, 3, 5, 6, and 7 all placed. Anything else that's in the universal set but not within those two goes in region 4. So we'll have a 0, a 1, a 4, an 8, and a 9. So then we can use our drawing to answer these various questions. So, for example, A complement, everything that is not in set A, but is still in our universal set. So as far as set theory, A is covered by regions 1 and 2, so the complement of that would be regions 3 and 4. So A complement, everything from region 3, everything from region 4. And close it on up. A union B complement. A union B covers 1, 2, and 3. So then the complement of that would be region 4. I'm listing out only things in region 4. So 0, 1, 4, 8, and 9. And finally, A complement intersection with B. A complement we saw before was region 3 and region 4. B, we're going to intersect that with B. B is region 2 and region 3. So everything that is in the intersection, so things in both lists, so that would be region 3 only. So A complement intersection B, region 3 only, so that contains just element 6. Okay. So that takes us through the Venn diagrams. Next to our friend Euler. You can kind of tell how much math someone's had by how they say that name. If they've taken a fair amount of college math, you'll hear them pronounce it as Euler. If not, usually you hear it pronounced as Euler. These are most useful if we have either disjoint sets which are sets with no elements in common, or proper subsets. See section 1.2 where we talked about proper subsets. So for this next example, our universal set will contain A, B, C, D, E, F, and G. Again, these are case sensitive, so make sure you're not confusing this element, lowercase a, with set, cap A. So case sensitive, make sure you're aware of that. If you're someone with that habit of writing everything in lower or everything in upper, break that habit now. All right, so set A will contain A, E, and G. Set B will contain B, D, and F. Now, if we were drawing the Venn diagram for this, the Venn diagram we draw it the same way each time. Universal set with the box, 2 subsets, so 2 overlapping circles, and here's set A, here's set B, here's region 1, 2, 3, and region 4. And we would just place things accordingly, so start with region 2, and I don't see anything they have in common, so region 2 would just stay empty. Region 1, things that are in A but not in B, that would be lowercase a, E, and G. Region 3, things that are in B but not in A, that would be Bravo, Delta, and Foxtrot. So we used A, E, and G, B, D, and F. So it looks like C goes into region 4. So that's just a quick little review of Venn diagrams. Euler would have approached it different. Euler would have looked at the sets and said, okay, A and B are disjoint. So he would have started the same way, big universal set U, but since they're disjoint, since they don't overlap, he would not draw the circles overlapping. He would draw them as separate circles. So here's set A, here's set B, and then within elements A, E, and G, elements B, D, and F, and C out there in the box, but outside of the circles. So we have A, B, C, D, E, F, and G all accounted for. So each element is in there one time. An example like the one before this, Venn and Euler would have drawn it the same way. If they were not disjoint and neither was a proper subset of the other, Venn and Euler would have both drawn them the way John Venn always did his. All right, squeeze it on there. We'll just go to the next page. So then our next one that we'll take a look at, our universal set, will be H, I, J, K, L, M, and N. Set A will contain elements H, I, and J. Set B will contain elements H, I, J, K, and L. So on this one, they're definitely not disjoint. I see right away they have at least one element in common. However, I notice that everything in set A is also contained in set B, and sets A and B are not equal. That means that set A is a proper subset of set B. So when Euler would sketch these out, he would have drawn them nested. So our big box is still the universal set as always. And in this one, A was the subset of B, so A would go on the inside. Whichever one is the proper subset goes on the inside. The parent subset goes on the outside. And then we start as far to the middle as we can. So we start in the middle of the bullseye. So everything that's in all three sets, that would be H, I, and J are in all three. So it's in the box, in the big circle, and in the little circle. That's going to drop them right here. So there's our H, I, and J. Then we just move out one step at a time. So now I want everything else that's in B that I haven't already written down somewhere. So that would be K and L. So those will go in the outer ring. And then in the box but outside of the circles, we have M and N. So they were part of our universal set, but not part of A, not part of B. So this is what the Euler diagram would have looked like. Go ahead and pause it and see if you can figure out what the Venn diagram would have looked like for that. Okay, welcome back. So Venn would have done it the same way every time. So there's our universal set U. There's our two overlapping circles. We put labels on them. Get our regions in there. And then place things in there. So in region 2, I want things that are in both A and B. That's H, I, and J. Then I want things that are in A but not in B. Nothing else to put in there, so region 1 would be empty. Region 3, everything else in set B that I haven't already put in the drawing. That's our K and L. And then region 4 is everything left in the universal set that we haven't touched yet, so M and N go out there.